Hi, in this question, we have the ideal batteries. Three batteries are given E1, E2, E3, and their voltages are 20 volt, 10 volt, and 5 volt. Then we have resistor combinations with each of 2 ohm. So the question is, what are the size and directions, left or right of the current I1? Does battery 1 supply absorb energy? What is its power? And multiple batteries, what is the current and what is the power? So what we will do is we'll start simplifying these resistor combinations. So we see across E2 and E3 we have two resistors of 2 ohm each in parallel, so the equivalent resistance will be 1 ohm. So we can say that there is a 1 ohm resistor across E2. Similarly, across E3 we have three resistors of 2 ohm, 2 ohm and 2 plus 2, 4 ohm. So equivalent is 0.8 ohm. This bottommost becomes 1 ohm because 2 are in parallel of 2 ohm and 2 ohm is another in series. So we can say 3 ohm resistor is there. Now I1 is the direction of the current given from E1. Okay, and so we'll write loop equation for this loop, and the loop equation works out to, so we'll start clockwise from 20 volts E1 battery. So that is 20 minus 10, because 10 we are going from positive to negative, and again in case of 5 volt we are going from negative to positive, so that will be 5. And then we have I1 current going through 2 plus 1 3 ohm resistor. So 20 minus 10 plus 5 minus 3 I1, presuming I1 has the same direction which they have given in the diagram, is equal to 0. So that means 3 I1 is equal to 15. So I1 is equal to 5 ampere. Now this current I1 is in the whole loop. That means that is the current that is going through E1. So question number 1, what is the size and direction of the current? So the direction of the current is what they have given in the diagram, which is correct because the value we found is positive. So direction of the current is from left, okay, to, clockwise I would rather put it. Left, right, your right could be my left. So point C, does battery 1 supply or absorb energy? Battery 1 supplies energy because there is a current in the direction from negative side of the battery to positive. So we can say that the battery 1 is supplying energy, and power is equal to E into I, which is 20 into 5, which is 100 watts. Now next is, does battery 2 supply or absorb energy? Now we'll look at battery 2. Battery 2 has equivalent resistor of 1 ohm across it. So that means current through this 1 ohm resistor would be E2 over 1 ohm, and E2 is 10 volt. That means current through this resistor is 10 by 1, 10 ampere. While the current in the circuit is 5 ampere. That means an additional 5 ampere current is being supplied by E2. Okay, so from its positive side to its negative side. So that is 5 ampere additional current being supplied by E2. So E2 is also net provider of energy, and that energy is E2 into I, which is 5 ampere. The 5 ampere current is coming through 20 volts battery, so 5 ampere is being supplied by it. So 5 into 20 is 5 into 10 is 50 watts. So now we have completed E and F. Okay, so let me write it. So please subscribe to my channel and remain connected. We'll have many more problems from the book added to the playlist. That is 50 watts. Now we'll move on to question G. G is does battery 3 supply or absorb energy. Now you would notice that battery 3 has an equivalent resistance of 0.8 ohm. That is 1 by 1 over 1 over 2, 1 over 2, 1 over 4, because there are two resistors of 2 ohm in series. So that makes equivalent resistance to be 0.8 ohm, and we have potential difference of 5 volt across it. That means current through the resistors are 6.25 ampere, 5 over 4 over 5. So now we know that there is a current coming in the same direction in which this battery is providing current. So total current through the circuit is 6.25 plus 5, which is 11.25. So 11.25 ampere is the current. So power is E into I, which is 5 volt into 11.25, that is 56.25 watts. So that is power of E3, and it is supplier of power. Thank you.